Voyager 1 is nearing one of the most extraordinary distance milestones in the history of space exploration. By late 2026, the spacecraft will be so far from Earth that a single radio transmission will require a full day to reach it. 24 hours for light itself to cross the gap. An astonishing reminder of both the immensity of interstellar space and the stamina of a mission launched in 1977. In this video, we'll look at what this milestone represents, the science behind it, and what lies ahead as humanity's most distant explorer continues its journey. Let's get started. Voyager 1's approach to the one light day mark isn't a discovery in the traditional scientific sense, but rather a historic positional achievement. It demonstrates just how far a human-made machine can travel when given decades of momentum and consistent mission support. Nearly 50 years after launch, the probe is on pace to become the first spacecraft far enough away that even light needs a full day to catch up with it. According to the most recent tracking from Earth, Voyager is already more than 23.5 hours away in one-way signal travel time, and that number increases little by little each day as it continues on its escape path out of the solar system. Voyager crossed the heliopause in 2012, the invisible boundary where the sun's charged particles and magnetic influence fade and interstellar conditions begin. Since then, it has been drifting through the interstellar medium, the extremely sparse plasma that fills the space between stars. The one light day distance corresponds to roughly 16.1 billion miles, or about 25.9 billion kilometers from Earth. NASA's Deep Space Network determines this using Doppler measurements and precise timing, though the task becomes increasingly challenging as the signal weakens with distance. Even so, despite aging hardware and continuously declining power levels, the spacecraft still transmits enough information to maintain communication. The idea of a light day may feel abstract, but reaching it signals a conceptual shift in how we describe space missions. Within the solar system, distances are normally measured in kilometers, astronomical units, or signal delay measured in minutes or hours. But once Voyager crosses the 24-hour threshold, it enters a scale usually associated with stars or interstellar distances. Though only a tiny fraction of a light year, a light day sits near the lower edge of how astronomers describe vast cosmic separations. This milestone alone shows how far this mission has stretched human presence into the galaxy. From this point forward, Voyager's journey leads it through empty interstellar space. There are no planets or major objects along its route, only a long, quiet drift farther into the darkness. Its speed remains steady, but even so, it will take centuries before it reaches the inner edge of the Oort cloud. The one-day milestone is just another marker of the mission's incredible endurance and the enormous scale of its voyage. Although the milestone carries symbolic weight, it also has significant scientific meaning. Voyager 1 is still the only operational spacecraft collecting direct, on-site measurements from the interstellar medium. Its distance is the reason its data is so valuable. The plasma wave instrument continues to detect the density and behavior of the interstellar plasma surrounding the craft. These measurements help researchers understand how the sun's influence fades with distance and how the heliosphere interacts with the surrounding galactic environment. By crossing the heliopause, Voyager has provided insights that refine theories about the structure of this boundary, the behavior of charged particles, and the forces that shape the outer edges of the solar system. The magnetometer aboard Voyager still measures the strength and orientation of magnetic fields in the region. These readings help scientists improve models of galactic magnetic structure and study how interstellar magnetic fields guide cosmic rays. Even small fluctuations in the data offer new clues about how the galaxy behaves on large scales. The cosmic ray detector remains important as well. Cosmic rays, high-energy particles from events such as supernovae, vary in intensity inside the heliosphere because of the Sun's influence. But Voyager, now far beyond that influence, provides a baseline measurement of cosmic rays that is unaffected by solar modulation. This helps researchers build a clearer picture of the interstellar radiation environment, a topic especially important for future crewed missions that will require protection from such particles. Over the very long term, Voyager will continue moving in the direction of the constellation Ophiuchus. It will reach the outer boundary of the Oort cloud in many thousands of years, long after it has fallen silent. In this sense, the approach to one light day is just another small step in a journey that will continue for an almost unimaginable span of time. Scientists also view the spacecraft's trajectory as a reminder of the enormous scale of the galaxy. Even after 5 decades of continuous motion at tens of thousands of kilometers per hour, Voyager is still astonishingly close to home when compared to the distances between stars. This perspective helps frame the immense challenges that future deep space missions must confront, not only covering vast distances, but operating reliably over timeframes far exceeding a human lifetime. Despite the limits imposed by age and distance, Voyager continues to offer valuable lessons. It forces mission designers to tackle real examples of long communication delays, low power, and unpredictable behavior at extreme range, scenarios nearly impossible to simulate on Earth. Voyager 1's approach to one light day marks a new frontier in how far human technology has traveled. Its final data continues to shape our understanding of interstellar space, and as it drifts farther away, it stands as a quiet reminder of how far curiosity can carry us. As the craft continues its slow journey into the deep, it carries with it not only scientific instruments, but a small piece of humanity. One day the last signal will fade, yet Voyager will keep traveling, silent, steady, and eternal. A message from Earth, wandering between the stars. Thank you for watching. If you enjoyed this deep space story, be sure to like, subscribe, and join us for more explorations of our incredible universe.